Thank you for attending. And really, my talk is hybrid inquiry-based learning in math for elementary teachers, and I'll kind of state some reasons for why I'm doing this. The background, students, so I'm talking about two classes for pre-service elementary teachers at my campus, University of North Texas at Dallas. College algebra is considered a prerequisite for the first course. And as I said, there are only two classes required for the whole degree for these students. And usually the students in the class are between 15 and 20, so this is really not that bad. And this presentation is part of a paper I'm trying to write, really, and it has to talk about the perception, or what elementary teachers' perception of this method, what's called hybrid inquiry-based learning, and what suggestions do they have to improve this method, if any. So usually, hybrid inquiry-based learning is a modified version of the inquiry-based learning, so it integrates the traditional teaching approach with the inquiry-based learning approach. It's not really complete inquiry-based learning. Inquiry-based learning can be the extreme of more method, or it's just kind of some version of a modified version of inquiry-based learning. Why did I choose to do this? I taught before geometry for secondary school teachers with inquiry-based learning, in fact, from Clark's book. And I've taught math for secondary teachers with a complete inquiry-based learning. I've taught this class, or these two classes, before in a traditional way, and then I decided, well, maybe it's not very appropriate to do it with inquiry-based learning, so I said, let's do some kind of transition. So I thought maybe hybrid inquiry-based learning would be a good transition to inquiry-based learning after students kind of get used to it. And one reason for that is students we have on campus, most of them are workers. Most of them are mostly mothers, have children, so they always complain about, well, I don't have time for all this. I have 12 hours, I'm a wife and a mother, and I have also full-time job. So I said, well, if I require them to do a lot of stuff and presentation and all this business with inquiry-based learning, I'll be in trouble. So the other reason that made me do the hybrid inquiry-based learning is what I call content restrictions. And given the fact that there are two classes for this degree, and no matter what we say, we have to cover certain topics so that these students will pass the certification exam in Texas. And in fact, nowadays, they require them not only to pass the test, they will have to pass every portion of the test, in particular, for example, mathematics. So that makes us more concerned about covering some material that will enable them to pass the test, at least once they finish their degree. So these are I would say, very standard topics in these two courses. Unfortunately, as I said, there are only two classes, and we try to cover these topics in course one. It's called Math 1350. I think this is even a common core numbering in Texas, 1350. So I try to cover these problem solving and logic, introductory set theory, numeration system and whole numbers, and then rational numbers, and then some real numbers if we can. Sometimes even I really don't get to that much because of the background of the students. And then the second course, it's called 1351. It's probability and 3D, introductory descriptive statistics, and some geometry. And in this approach, as I said, it's kind of modified version of inquiry-based learning. So I use this very traditional book, Problem Solving Approach to Mathematics for Elementary School Teachers by Polston. This is a very standard book for this course, I would say, in the traditional way, attached with my MATLAB. And for the IBL thing, in the worksheets and stuff, I used Introductory Mathematics Explorations for Elementary Teachers by Mark Daniels, and we thank him for at that time he didn't have it for publisher yet, so we were able to get it for free. So I just printed it out and to give it to the students. So. And the way I would say generally the teaching will go, I'll give a brief interactive lecturing with clicker questions. So at the beginning, maybe for 20 minutes, sometimes 15 minutes, just kind of give some topics, and then I'll distribute some worksheets and make students work on them, just active learning way, and then ask them to do presentations. And of course, we'll do discussion at large, and then I'll ask each student to write his or her solution in what we call portfolio, and I will come to this in the assessment in a minute. For the evaluation of the course, I require presentations. Portfolio, the way I did portfolios, each student, at the beginning first, in the first course, I required them to solve really a lot of problems, and each student, I usually collect the portfolios without prior notice, so at any time I can call the portfolios. They should have their portfolios at any class, and I grade them, return them back with a grade of 0 to 4, and each student has the chance to redo the question again, and then I will take the average. They can do the question as many times as they want. They can repeat the solution as many times as they want. In the second semester, because I discovered this is a lot of work, so I reduced the number of problems in the portfolio, and I was not grading every single problem. I chose random problems, I graded them carefully, returned them back to the student, and I asked them for certain problems, I will make it kind of must, they must do, and then if there's 3 out of 4, I will give them the choice. If they want, they can redo it again, and if they get 4, then they will get the average. And they can do this as many times as they want. For projects, 1 or 2 projects usually, and it's group projects, and it has to do something with education. So for example, how would you use Venn diagram to teach something in elementary school? Something like that. So it integrates some of the education into the course. I used 2, I would say, regular standard exams, midterm and the final. And for the quizzes, I used 2 kinds of quizzes. Quizzes on MyMathLab, and the way I did it on MyMathLab, I conditioned the quiz to open for homework that the student must get 75% or more to get access to the quiz. And then they just get to do the quiz online on MyMathLab. It's usually attached to the textbook. So that was not really much of work for me, except the students complain a lot about that. And also I did, to mention here, in-class quizzes. The class was Monday, Wednesday, I remember. Each Wednesday we'll have a quiz. And these quizzes, sometimes I do them on group basis, but I usually don't tell students that they will be working in groups. So sometimes I allow them to work in groups, other time I just make them do individually. And the way I approach this usually is kind of concept approach. So the problems that I would put in worksheet are not traditional. I would say problems that would require some discussion and manipulations, something like that. For example, 4 people plan to drive an equal amount of time during 16-hour car trip. The first driver accidentally drives 15 longer than he should have. If the other 3 people evenly divide the remaining driving time, how long will each of the 3 people drive? And this is like a discussion within group, and then you start discussion at the class, and some students or some groups will send it. A question, for example, in probability, what does it mean that when tossing a fair coin, the probability of getting ahead is 1/2? So we'll ask them to write, what does this mean? And then we'll have some discussion about that. Just basically, I would say, non-traditional questions that will open some discussions. That's rather than technical questions. Now, the problem with this is the way students, most of them like it, especially in the second course, because at the beginning they really didn't like it at all. Some of them even complained to the dean because it's a lot of work. And for example, these are some comments from the students. I ran a survey after each class and tried to get what is their perception. So for example, it helped me understand better, need more of these exercises. These are, as I said, comments from students. Presentation made me confident about my teaching ability. I think the homework was plenty. This is, I think, from the first course. And I loved my MATLAB. However, it was different from class. As I said, in class we just do non-traditional problems, when my MATLAB is just computation and all these things, so they didn't like that. And then we need worksheets with problems that will be on the exam. This is one of the complaints, that they complain, they spend a lot of time, they come to the test, it's not like what we did in the class. And they really, these guys just want to finish, and they always complain, why do I need to learn this? I just need to class and go and teach. We had to learn a lot of information in a short period of time. It was overwhelming, but I learned a lot. I liked the group work. This is a class in which you have to think, and so on. The challenges for me were at the beginning, they really resist that, and they started comparing, to the previous math classes, like usual college algebra, in which some of them even take online, and they just, even sometimes they don't go to school and get A or B. Compared to this, a lot of work, and some of them don't get good grades sometimes. Students' background, the prerequisite is really college algebra, but some of them even don't know fundamental algebra. This really was a problem. And other stuff, which is, I would say, in most classes, most students can solve technical problems, but when you put them in a discussion or something like this, they're really stuck. And then, this is a very common thing in these classes. Students are not used to spend time on the problems. They just spend 2 minutes. I can't do this. This is too much. All the time they say this. Recommendations. I think we should, at least now I'm proposing, requiring 4 math classes rather than 2 in a college algebra. So we'll just say, hey, we don't need college algebra. Let's teach these kids what they need rather than college algebra. And we will propose 4 classes like that: problem solving, real number and algebraic thinking, probability and statistics, and geometry. I think if I have the chance to teach this content in 4 classes rather than 2, then I will be able to do inquiry-based learning, complete inquiry-based learning, and maybe even in a better way than this way. And as I said before, usually I integrate, sometimes I teach in the teacher education, the methods courses, and that's sometimes I integrate some kind of modeling of teaching and stuff in that course. So given the fact that if I have 4 classes, I will be able to do this more. And I would recommend more emphasis on concepts rather than technical questions, because technical things they can learn at any time and teach their kids. And that's all about it.
All right, we have plenty of time for questions.
That was us to do this.
Okay.
If you go back a couple slides to the bullet points, usually I talk loud enough. I can use this. Is it on?
It's for the video.
Oh, back further, where you listed, there, that's it.
Okay.
Okay, comments. Okay. So then, and the next one. We teach 2 general studies mathematics courses in a blended fashion. We use My Math Lab. We have quizzes and tests online. We also have a weekly meeting where students solve problems in groups and then process them as a whole group. And while there are good things about that, there is a clear disconnect between the computer-assisted instruction and what we're trying to do in the problem-solving sessions. And if you come up with a solution for that, I'll be happy to communicate with you, because I don't have it.
I have this common thing in all classes, all elementary classes. Students do really well in My Math Lab because of the help and because of the fact the problems are technical, but they really don't do well in the in-class quizzes, for example, something like that. And they always complain, how come I do really good in My Math Lab, but not good at all, for example, in your tests in class or something like that. But the way I look at it, it has some advantages. If a student don't have help or something, they can go at any time and start doing it. But I agree with you completely that it has really bad things about this one. Yes.
I didn't mean to say it was bad. I mean to say it is a problem. I'm looking for a solution.
Well, my question will be, from the first course to the second course, what was the percentage of passing?
Yeah, that's a good question. Well, passing means in this class C or better. So D, they have to do it again. For example, in 1350, I remember having like 18 students. There were 2 Fs and like 3 Ds. That's 25% failing there. And I was not really hot. Like if I really want to do what I want to do, it would be more. But it's just something at reasonable standard. And now in the second part, it's a little bit better because students, get to know more, and they're more used to your style, and so less complaints and more willing to work and stuff like that.
So I walked in a little bit after you had already started, so I apologize for this. But I noticed on one of your points you had said that the students were asking for more worksheets that are going to be on the exam, like you just pointed out. And I noticed that with hybrid courses or sometimes with IBL courses, the assessments are hard to align with the curriculum or the methods that you actually use. So do you find that there are any other ways that you, I guess, mediate that problem?
Yeah, once I saw this comment, I started doing review sessions. Like we have a math lab, and I start going like 2 weeks before the exam or something, and start helping them and solving, I would say, traditional questions that they might come up, or they think they might come in the test or something. But you know, the fact is, it's not a matter of the test only. I try to tell them that way. It's just you need to learn how to think. That's the whole point of the course. It's not the material itself. It's just improving your critical thinking. But
So what it sounds like I'm hearing is that you didn't change the assessment itself. You changed
No,
the way that they were learning? Or
yes, I didn't change the assessment. I started giving more review sessions, or you know what they call worksheets, more traditional, or I would say hybrid traditional, some kind between traditional and IBL. So they will get used, because that's what they're used to. And if we want to change, we can't jump. We just need, I would say, smooth transition between, you know, these guys are used to, give us this worksheet, the test must be out of this worksheet, and that's all I know. I don't do that in my classes usually, and that's why at the beginning, especially in the first class, they resist this a lot. They just, I can't do that most of the time.
So where do you think would be an appropriate space to start transitioning from the more traditional assessments to something that would reflect more of an IBL learning process?
I would say after, you know, students and administration, like for example, the dean, the chair, people getting more used to it, which is the case now more because I'm teaching more courses and more of these. Because, you know, once the students finish the class, they realize that. So they start telling their peers about that, and students are coming now, and I usually tell them, hey, it's just a matter of a month or two, and then you will see the difference. And I think we'll make a difference at the end.
We have time for another question.
What mechanisms do you put in place at the beginning of your class to reassure students that they can be successful with this new enterprise, that they're, you know, with an IBL approach? What mechanisms do you have in the course so that they feel like they're not just going to fall on their faces?
Right. I first try to have a discussion with them at the beginning. For example, the first meeting, I basically don't teach mathematics. Start to ask them the fact, for example, how you guys did you learn to drive? Have you just watching someone driving and, you know, some kind of convince them? Because the problem, in my opinion, these guys are not convinced that they need this stuff, and they will, you know, they think that they will go and teach 1 + 1 = 2, and that's all. The second thing is the work, the group work. Like, you know, you just learn from your peer and you teach them sometimes. And the third is being available all the time in my office. I usually go to office really early and stay late, and start to encourage them to come at any time and have discussion with me about what's the problem. And you realize that many of them, just because they took, for example, college algebra online, they have no idea of what even college algebra is about. And they pass the course, and then start to convince them, you know, you should not do that, because at the end, you need the knowledge, not the grade. And just, you know, try to be on that track all the time with them. So some of them will realize that, I would say. Some, of course, they just keep the class.
So let's thank Ollie again. Thank you very much.